Hello everyone, my name is Ryan Davis and this is Red Black Trees. So what exactly is a red black tree, you might ask? Well, a red black tree is a type of binary search tree that's able to automatically keep itself balanced. This means that for insert, delete, and search, it'll always take O log n time, even in the worst case. Pretty cool, right? It does this by adding a feature to each of the nodes, that feature being a color, red or black. Just by following a few simple rules about how red and black nodes are arranged, the whole tree stays in balance without having to rebuild itself. Now, let's dig deeper into those rules I just talked about. Red and black trees have 5 key rules that each tree has to follow. Those rules being every node is either red or black, the root is always black, all the empty or null child spots at the bottom of the tree are considered black nodes, red nodes cannot have red children, and lastly, every path from a node down to its leaves must have the same number of black nodes. By working together, these 5 rules make sure that the tree stays balanced, which means that no path becomes much longer than the others. So when would you actually want to use red-black trees in your own programs? Well, actually, red-black trees are built into a lot of tools you probably already use. For example, both stdmap and stdset in C++ are implemented using red-black trees. This means anytime you're storing key value pairs or unique elements in sorted order, you're already using red-black trees, even if you didn't realize it. This makes them great for anything where you need fast access to sorted data. One common use is with ordered maps or sets, where you can insert, delete, and look up elements in O login time, all while keeping everything in order. Another cool example is priority maps, where you can store tasks or jobs along with their priorities, and always grab the next one in line quickly. You'll also find red-black trees useful in simulations or games where future events need to be scheduled by time. By using a map of time to events, you're easily able to trigger actions in the right order. And lastly, red-black trees can help build an undo-redo system. You can use maps to store actions by version number or timestamp. And since the maps keep them sorted, it becomes super easy to move backward or forward through the user's history of changes. So overall, if you're managing data that's constantly changing but still need it to stay sorted, red-black trees are definitely the way to go. Now that we've talked about what a red-black tree is, the different rules of red-black trees, and where you can find red-black trees being used, let's now look at how red-black trees actually stay balanced. Well, every time you insert or delete a node, you might break one of the tree's 5 key rules. An example of this would be like ending up with 2 red nodes in a row, or having different amounts of black nodes on each path. When this does happen, the tree fixes itself by doing something called rotations, and if that doesn't work, it uses recoloring. A rotation is a way to rearrange the tree while keeping its sorted structure intact. Rotations have 4 main ways it can operate. A left rotation is where a node shifts up to the left and its right child takes its place. A right rotation is the opposite of a left rotation, meaning the node shifts up to the right. And then there is left-right and right-left rotations, which are a combination of the two. Recoloring, on the other hand, doesn't move any of the nodes. It instead flips the color of some of the nodes to restore balance. An example of this would be if both a node and its parent are red, the tree might recolor them and their uncle to fix the violation. Although you usually don't have to manually handle these, if you're using something like stdmap in C++, it's still important to know that they're happening, as that's what's keeping the tree balanced, and it keeps all the operations running in O long n time. Okay, so here I wanted to look at some actual C++ code that implements red-black trees. And so to do this, I created a simple task scheduler which uses stdmap, which as said before is implemented with red-black tree. So first thing I did was I started by inserting a set of tasks into the map. Each task is assigned a priority number, where lower number means higher priority. And even though I'm inserting the task in no particular order, the red-black tree ensures that they're always kept sorted based on their priority values. So here I have 10, 20, 15, 30, 25, 5. It's not really in any order, but the red-black tree is going to make sure that it's kept, 5, 10, 15, 20, 25, 30. We can see this as here I print it out. When it prints out, it's going to come out in ascending order. That's because the tree maintains balance using rotations and color rules, which keeps the keys ordered at all times. We'll see that in just a second. Next thing I did was I wanted to, erase the task with priority 20. When we delete from a red-black tree, it automatically rebalances itself to maintain its performance guarantees. So even after removing a task, the rest of the map remains correctly ordered and balanced. So we'll see this as I open a new terminal. We see first that it's getting printed out, 5, 10, 15, 20, 25, 30. It's getting printed out in ascending order. Here, once you remove 20, it's still 5, 10, 15, 25, 30. It's still being printed out in order even though you erase something. Okay guys, thank you so much for watching. Through this tutorial, we found that red-black trees are efficient, widely used, and incredibly reliable in practice. They maintain balance by using node colors and a set of rules, especially during insertions and deletions, which is what keeps them so fast and consistent. Operations like insert, delete, and surge are all guaranteed to run in O login time. That level of performance is super important when working with large and changing sets of data. If you're ever building something that needs sorted data and fast updates like a scheduler, map, or any system with dynamic ordering, red-black trees are a great tool to use. Again, thank you so much for watching, and I hope this helped you understand a little bit more how red-black trees work and where they can be applied. Thanks again.